morning, dear friends. Hopefully, you all are good, enjoying your learning. In last couple of video lectures, we have discussed about the refraction through the glass slab, total internal refraction, reflection through the glass prism. In this lecture, I will tell you about specifically about the refractive index of medium and different aspects. I hope you are utilizing your time in learning the things in your own way, and hopefully this new mode is definitely suitable and more effective, that we will come to know very soon in the feedback session. So please watch this video about the refractive index. Keep watching, keep learning. Good morning, dear students, my friends. In this video lecture, I will discuss about the refractive index in detail. In so many last topics, we have considered this term. What does refractive index mean? That is very important to understand. You all know that optical media are of two categories, rarer medium and denser medium. These two media are categorized on the basis of the speed of light in the medium. The medium in which speed of light is faster is considered as rarer medium, and the medium in which the speed is slow is considered as denser medium. And we know that when ray enters from one optical medium to another optical medium, that is either from rarer to denser or denser to rarer, it deviates from its original path. So refractive index is the term related to the bending ability of the medium towards the ray of light. So mathematically, refractive index is given by if the ray is entering from rarer to denser, then we know the ray bends towards the normal. This is normal. This is incident ray. And this ray is refracted ray. If this medium is taken as 1 and this medium as 2, in this medium speed of light is V1 and in this medium speed of light is V2. Then refractive index of second medium with respect to first medium is mu 1 is equal to V1 upon V2. It means it is a ratio of a speed of light in first medium to the speed of light in second medium. The first medium means the medium from which the ray is entering, and second medium is the medium to which the ray is, you can say, traveling. So that is called second medium. So we can have mu 1 is equal to V1 upon V2. Similarly, when the ray is traveling from denser to rarer, then it bends away from the normal. These two angles are considered as angle of incidence I. This is angle of reflection R. Here it is angle of incidence I, and this is angle of incidence R. Let the denotation remain same. This is first medium, this is second medium. Speed of light in this medium is v1. Speed of light in this medium is v2. In this case, refractive index of first medium with respect to second. So one thing is very clear, the refractive index of the medium is taken in which the ray is refracted. So it is mu12 is equal to v2 upon v1. So I hope you understood the concept of refractive index. It is the ratio of speed of light in medium from which the ray is entering to the speed of light in medium to which the ray is entering. So when it enters from rarer to denser, then the refractive index of denser medium, which is second medium here, given by mu21 is equal to v1 upon v2. When it enters from denser to rarer, then refractive index of rarer medium is taken, and it is given by mu12 is equal to v2 upon v1. To overcome these kind of comparison, we are taking some another term known as absolute refractive index. Absolute refractive index is the refractive index of any material medium with respect to vacuum. Refractive index of any optical medium with respect to vacuum. So it is mandatory now, the rays entering from here we have taken vacuum, and any medium here we are taking. So rays entering from vacuum to the medium. In that case, speed of light is given by c, and here speed of light is given by vm. Then mu m is equal to c upon vm. This is the concept of absolute refractive index. So in absolute refractive index, it is mandatory that the ray should enter from vacuum to any other optical medium. Now one thing would be very interesting to learn, that refractive index is always written for the denser medium. The rarest medium is vacuum, in which the light has fastest speed, and all the tables are given for the absolute refractive index of the optical medium. So that is given by mu m is equal to c upon vm, and c is always 3 into 10 power 8. So this formula will become in this form also. Mu m is equal to c into 3 into 10 power 8 upon Vm. So by knowing the refractive index, we can find the speed of light in that particular medium. So this is about the absolute refractive index and the refractive index is there. One more thing you can understand from this equation first and second, that mu one two is equal to mu 2 1, or mu 2 1 is equal to 1 upon mu 1 2. Now I would tell you one more interesting thing, that we have two expressions for the refractive index. One is from the definition, also from Snell's law. Mu is equal to sin I upon sin R. So this sin I upon sin R is the ratio of sine of angle of incidence to the sine of angle of refraction, that you can see in both mu 1 2 and mu 2 1 also. One thing is very interesting to know here, that what happens if the ray is entering from one optical medium to another optical medium along the normal. If the ray is entering along the normal, then theta I would be 0, and you can see the ray goes straight. So theta R is also 0. In that case, Snell's law is not followed. It means you cannot express the refractive index of a rarer, denser medium with respect to rarer medium by using Snell's law. So Snell's law will not be followed if the ray is entering from one optical medium to another optical medium along the normal. This can be taken in both the directions, either from denser to rarer or rarer to denser. The ray will go straight without any bending. So Snell's law is not followed, but we can use the definition of refractive index, that is mu is equal to speed of light in first medium to the speed of light in second medium. That can be followed here, but it's very clear for this specific case when the ray is along the normal, then Snell's law is not obeyed, and rather the ray is not bending. So I hope you have learned about the concept of refractive index in this video lecture. Thanks for watching this video. Many more are to come. We will meet soon in the next video lecture. Keep watching, keep